Hello, and thank you for watching my YouTube channel. I'm so happy you are here with me today. And today we are going to go into predicting stock prices with Python. So this is going to be a step-by-step guide to LSTM and data preparation. And we're going to be using Jupyter Notebook. So first off, I just want to do a little disclaimer. This presentation is for educational purposes only and is not financial advice. So these techniques and models demonstrated here on this video are designed to showcase data science methods and should not be used for actual investment decisions. Always consult a financial advisor before making any investment choices or decisions. So I just want to welcome everyone. Today I'm going to dive into an exciting interaction of finance and data science. So we're going to be doing a predicting stock prices using Python and machine learning. And in this video, I want to explore how to harness Python's power, especially using Jupyter Notebook to create a predictive model for stock prices over the next 30 days. So my goal is to help you understand how you can use historical stock data as a foundation to make informed predictions. We'll start by pulling historical data from Yahoo Finance, preparing and structuring this data to suit our model's needs. And from there, we'll apply an LSTM neural network, a type of deep learning model designed to capture patterns and sequential data. So throughout this process, we'll cover essential data science techniques, including data ingestion, data preparation, data modeling, and evaluation. By the end of this video, you'll not only have a functional code to forecast stock prices, but also a deep understanding of the challenges and considerations involved in time series forecasting. So whether you're a data enthusiast, financial professional, or simply curious about the potential of machine learning, this presentation will equip you with actionable insights, hands-on approach to stock price prediction. So let's get started. So first off, I want to just be able to explain to you what LSTM is if you don't already know. So the ones that don't know, LSTM is basically long short-term memory. So this is a type of neural network architecture within the field of deep learning, specifically designed for handling sequential data and time series prediction. So LSTM networks are particularly good at learning from and making predictions based on patterns in your data that have time deficiencies, such as stock prices, weather patterns, or language sequences. So why use LSTMs? So LSTMs are ideal for situations where the order of data points is essential and where patterns over time impact the outcome. For particular tasks like stock pricing prediction, speech recognition, language translation, and video analysis. So in short, LSTM networks are a specialized type of neural network designed to learn from sequences over time by maintaining memory of previous data points. So it looks back at previous data points and makes that prediction for accuracy for data and time-based patterns. So in this video, I want to go over a 1 to 9 steps. So these are the steps we're going to go over in Jupyter Notebook using Python code. So first off, we're going to load the stock data from Yahoo Finance, and I'm going to show you how to do that. Process and scale the data, prepare and training data by creating future and target sets. We're going to build the LSTM model architecture. From there, we're going to train the model with the training data. And then we're going to prepare data for generating future predictions. Number 7, we're going to generate the 30-day forecast using the model. And then we're going to transform predictions back to the original scale, which I will show you how to do that. And then we'll finish it up with a visual of the historical data and the 30-day forecast. So we will get started into Jupyter Notebook now. Okay, so here I am in Anaconda Navigator. So if you're not sure how to download this, I will put the link in the description below. So once you are here on this window, what you'll do is you'll go ahead and click on Launch for Jupyter Notebook. You will see then it is launching. Okay, so now once Jupyter Notebook has opened up, we will go ahead and create a new file. So simply just go up here, it says New, and click on this first one, it says Python 3. Okay, so once it opens up, you will see something like this. So this is your cell here, and you can go ahead and start creating your cells. You can push this little plus sign to add more cells. Before we get started, I just want to let you know that we need these necessary libraries. So if you don't already have these installed into your Jupyter Notebook, simply just go ahead and put in this code here, install TensorFlow, Yahoo Finance, and then these other ones as well. So I will go ahead and copy this and put it into the first one here. So to install this, you basically just use these codes and you would hit your run button. But in this case, I already have it. So I'm just going to go ahead and put a little, the, the number sign in front of it. So with this pound sign in front of the code, Jupyter Notebook will just run it as a text instead of an actual code. And also, I want to just explain that you can do this one at a time. So like if you just want to have this one, the TensorFlow downloaded, you can just do that one. You don't need to do all of them. Just keep in mind what you already have installed and what you need installed. So the ones that you need installed, just go ahead and code it in here and run your code. Okay, so next I'm going to do my libraries. So I'm going to just do a little um, text or message saying import libraries. And I'll start importing all necessary libraries in my code. Also keep in mind that I'm going to be importing TensorFlow and Yahoo Finance. So if you get an error message, just remember you need those to be installed, which is what I have up here. I have to put a space here. Okay, and some of these, when you run your code, you will get a warning. So this isn't something you have to do, but in this case, I like to use this because I don't want to see the warnings. So I'll use a code just to ignore these warnings. So I'm going to import to ignore warnings. So I'm going to import warnings, and then I'm going to call that warnings. Filter warnings, and I want it to ignore. Let's run it. Now that I have a number here, it's showing me that it ran okay. So now that I have all of my libraries, the next thing I will do is we will go back to my steps. And in my list, it says load the stock data from Yahoo Finance. So that's the first thing we're going to do after we imported our libraries. So let's go ahead and highlight that, showing that we're doing that step. So now I'll go ahead and put a little note here. So step 1, we will be doing download stock data. Another note here saying I want to choose a stock ticker symbol. So in this case, we're using AAPL for Apple data. So this code, I'm going to call it ticker, and I'm pulling this from AAPL data, which is the Apple data. Next, I want to download historical data from Yahoo Finance. And to do that, I'm going to call this data. I'm going to call it from this code here, yf.download. And I'm going to call this tickler here that I just created. So it's going to be ticker, comma, start. And I'm telling it to start from the date. So I'm going to do a start date of 2020 of January 1st. And I put 2 of those little quotation things here. I just need 1. Now I'm going to put comma. Let's see here. Start equals. Sorry guys about that. And then just put your comma there. And now I want it to end my date time function. Today. Open and close parentheses. STRFTIME. And then these little symbols here. Telling it to do year format, month, and day. Next line, I'm going to put another message so we know what we're doing. So I want to focus on the close prices for simplicity. Okay. Okay, to do that, I need to call the data equals data and brackets. Put 2 brackets there. Open brackets, and then call your variable, which is the close. And now you're going to do 2 closing brackets. And that should be your code there. And I'll go ahead and run this code. Date time dot. Oh, let's see what I did here. So end date time is going to be dot date time again, and then dot today. So we're going to run this, fixing that, and here we go. Now it says 100% completed. Also, I want to explain this AAPL. So AAPL, again, I'm pulling this Apple data. I'm going to go over the ticker. In step 1, AAPL is simply the stock ticker symbol for Apple's data, right? So there's other ones as well in the stock market. So each company is represented by a unique ticker symbol. So that makes it easy to find and track its data. So examples, so if you want to go ahead and use Microsoft data instead, you would just use the MSFT. Or if you want to use the Tesla data, you would use TSLA. Also Google, you would just use GOOGL for Google stock data. So again, you would just replace those, like if you want to do Tesla, TSLA, that's all you would have to do is replace that TSLA. And if I run it, it will say complete. So it's pulling the data, stock data from Tesla. But in this case, I want to go back to Apple. So I'm going to copy that again here in my text and paste it down here, run it again. That was just an example of, in case you don't want to use Apple data, you can use Microsoft, Tesla, or Google. Okay, so now that we did number 1, we're going to go ahead and do number 2. We're going to scale the data. So I'm going to go ahead and highlight that. So this is the processing to scale the data. So here I am going to put step 2. Okay, step 2, I'm going to process the data. So I'm going to use the min-max scaler to minimize the data between 0 and 1. So we need for this to work and for our predictions. So I'm going to give you more of a detail on what I'm doing after I enter in this code. So to do that, I need this code here. I'm going to name this scalar equals, and then I'm going to use the function min max scalar. Next, I'm going to scale the data for training. To do that, I'm going to go ahead and use a different one called scaled underscore data equals. You can see this is my data set, which I called it up here, right? Scalar, I'm calling this so it could transform and fit into data, a scaled data. So I'm going to run this. As you can see, I've just received an error message and I see what happened there. So scalar.fit transform, it needs an S. I will go ahead and run that again. And there we go. Just going over this step, what we're doing is we're preparing the data so that our model can understand the use for prediction. So here's what we're doing. We're scaling the data by using a tool called Scalar and to transform our stock into valuables between 0 and 1. So this makes it easier for the model to work with the data and improves its ability to learn patterns of stock prices, because these stock prices can vary widely. So it could be from $1 to $1,000. So scaling them into a smaller range keeps things consistent. So this helps because, say, for example, imagine trying to compare two different types of numbers, right? So we can like for example, inches compared to miles. So it can be tricky because the numbers are a very different scale, right, between inches and miles. So scaling the data puts everything in a simpler scale. This makes it easy for the model to see patterns without being affected by large differences in the numbers. So in this step, we're making our data simpler for the model to understand and to transform into a smaller, consistent range. So I hope that helps out clear up anything. So the next step we are going to do is we will do step number 3. And let's look at my list here. And step number 3, we're going to prepare the training data by creating future and target sets. So I'm going to go ahead and highlight that yellow because we're going to go ahead and do that next. Now step number 3. So we're going to go ahead and put 80% for training data. I'm going to run this code. So it gave me a number, so everything's good. So we'll add another one under here. Next, I want to split the scaled data into training sets. I will go ahead and run that one. And I forgot to put a closing parenthesis here. And now it ran smoothly. So now that I did 80%, then I split my data. Now I want to create empty lists for futures X train and target Y train. And just you put in those two brackets, which is your empty lists, and do the same for your Y train. I'll run that code. I'm going to add a few more cells. I don't have to keep hitting that. Okay, now I want to populate the X train with 60 days of data and Y train with the following day's closing price. So we want to go ahead and grab those last 60 days of data so we can be able to predict the next 30 days. So this is the past 60 days. This is going to be the target for the next day's close price. I'm going to go ahead and run that. Closing parentheses does not match. So here, yes, see how there's an open bracket. I put a parenthesis. I need a and a parenthesis. There we go. So that was my mistake. I didn't put a bracket and a close parenthesis there to close the. Okay, so now we will convert lists to NumPy for model training. And I will run this code. It went good. So this one, I'm going to reshape the X-train to format. So this is required for the LSTM model. Okay, hoping I don't have any typos in my code, I will go ahead and hit run. And everything went smoothly. Okay, so next I want to show you number 4. We will build the LSTM model architecture. So I am going to go ahead and highlight that yellow. So step number 4. We want to build the LSTM model. So I'm going to run this code. Next, I'm going to do the first LSTM layer with 50 units and return the sequences. Run that code smoothly. Next. So we want to also model add drop. So I'm going to go back in here and add it in this cell here. So I'm going to go ahead and hit enter and put model dot add drop out, which is 0.2. So I'll write a little note here. This is to drop out layer to prevent like overfitting. So it's telling the model to stop at 0.2. So again, I'll go ahead and run that. So let's do the second layer. So that's the first. This is going to be a second layer, which is the LSTM layer. And again, this is just for the dropout layer to prevent overfitting. So I'm going to run this code. I have to make sure it was a comment. Here we go. There we go. Now I'm going to do the dense layer with 25 units. It is very case sensitive, so make sure you're putting in the right text. And I'm going to run this code. Perfect. So I put here 1, so I'm wanting to do 25 units. So I'm going to change that 1 to 25. There we go. And the next one is going to be the output layer with 1 unit. So we can just copy this and paste this in here. But I want to put a little message that this is going to be the output layer with only 1 unit. So this is the predicted price. And we can change this 25 to a 1. And I will run that. Now I want to compile the model using Atom Optimizer and mean squared error as the loss function. So I will put that in here, compile. The code is model dot compile optimize. And I will run that code. Perfect. So now we just did step number 4. So all this right here is building the LSTM model. So now we have that done. Now we can go ahead and go into step number 5. So now we're going to prepare it for training the model with training data. I'm going to add more cells here. So again, my message, step 5, train the model. I want to train the model with batch size of 1 and 1 epoch. So we're going to have it model dot fit. I will go ahead and run this code. It's still thinking, as you can see the little star there. And now it's running. Okay, so this step 5, I want to go ahead and kind of give you a breakdown on what we just did. This step is part where we actually teach the LSTM model to recognize patterns in the data so that it can make predictions. So like, for example, the X train and Y train are the data prepared earlier, right? So we prepared that earlier. X train holds the sequences of stock prices from the 60 days of historical prices, while Y train holds the next days of prices. The model uses this to learn. It looks at X train to see the past patterns, and it tries to match it with the Y train, which is the next day's prices. So for this batch size, this refers on how many samples or examples the model will look at before updating its learning. So setting batch to 1 means the model learns from one example at a time. This can help the model learn details more carefully, but it may take longer to train. And then this one here, the epochs 1. So an epoch is one complete pass through the entire data, the training data. So epoch equals 1 means the model goes through the data just once. So in practice, you might want to increase the epoch count. So say like, for example, you can do 10 or 20. So this will help the model learn better. So in this step, we're telling the model to learn from the training data by looking at one example at a time, which is the batch size 1. And then it goes through the data once, which is the 1 epoch. For better results, you can increase the number of epochs so the model has more opportunities to learn and improve these predictions. So now we are in step number 6. So we're going to prepare data for generating future predictions. And I'm going to write my message, step 6, which is prepare the data for 30 days forecast. So let's take the last 60 days from the data set for generating future predictions. So I'm going to run my code as last 60 days equals scaled underscore data minus 60, and then close brackets. So I will run that code. Perfect. The next one, I want to reshape Okay, I will run this code. Perfect. So now number 7, we're going to generate 30-day forecast. So now we're going to do a prediction of the next 30 days. So this will be step number 7. So generating the 30-day forecast using the model. You want to create an empty list to store predictions for the next 30 days. And to do that, we will use this code. So make sure you space this so it's going to be 4. So this one's a little tricky, so you're going to go 4 space underscore space in range 30, which is our 30 days. So I'm going to put a little note here. So you can change this if you'd like. So say if you want to do 30 days, you can, but you can change to 60 days to predict for 60 days. in this case, we're going to keep the 30. Last 60 days. So don't get that confused. So we are trying to look at the last 60 days to predict, just to keep that in mind. You can also use that code here that we use the last 60 days up here. If you want to do more days for predictions, that would be good if you are using more days for predicting in the future. The more data that you get in the past, the more it helps you for more days in the future. Just keep that in mind. So this is your code. So create equals model. This is your prediction, X underscore future. My R, P, R, E, D. And closed. I'm going to go ahead and add a note. So this is add. Put another note here. So I'm going to do update X future, which is our function, right? Name with the new prediction by removing the first value and adding the new prediction. So to do that, we will put a note indicating that. Code here is X future equals MP. Now we'll run this. And I got an error. So here, I think I put too many. There we go. So it ran the code. So when we run the code, each step, so this is a prediction for the next day, right? So this is generating one by one in a sequence. So one step every single day. So there should be 30 here since we did 30 days. So it's trying to predict those days. So these steps represent the process of the model predicting the stock price for each day in the next 30 days. So next step number 8. So we're going to transform predictions back to the original scale. So I will indicate step number 8 and transform predictions back to original scale. So I'm converting the scaled predictions back to the original scale using inverse transform. Okay, so let me create this code and I'll tell you exactly what it is. So future. I'll run this code. Perfect. Okay, so if you guys remember, we scaled the data, right? So we were scaling it so that it could kind of group the numbers in a better scaling for a better prediction. So we grouped them by zeros and ones, right? So we used it by normalizing the data range. We it makes the data easier for it to perform and read, right? So in this step 8, this takes the scaled prediction and reverses the scale, turning them back into real stock prices. So it's like there were stock prices, then we scaled it into zeros and ones for better predictions, and then now we switched them back to stock prices. So this makes the prediction meaningful by putting them back into the original dollar terms. That's what we did here. So now we will go ahead and do our last step, which is step 9, a visualization. So we're going to visualize the historical data and the 30-day forecast. So this is where we're actually going to start looking at things. So step number 9. Okay, so we're going to create a data set to hold the 30-day forecast with dates. So to do that, I'm going to enter this code, cast underscore dates, and this code is pd dot date underscore. Okay, so now I want to go ahead and do a plot historical data and future predictions for comparisons. I'm going to start writing up my code for that. Two dashes. X label will be your date. Your Y label will be your stock prices. Anything in red is your output. So that's what's going to show on your visual. Okay, so let's run this code. So it gave me an error. So I forgot a little quotation here, single quotation, and let's run that again. So as you can see, it's saying I have a closed parentheses here. So this one is matching with this one. So I am supposed to have a bracket there, just a bracket. So I'm going to take that parentheses out. And now I have these two open and closed parentheses and then this two brackets. And I will run that code. And you can see I spelled labeled wrong. So I have L-A-B-L-E, and it should be L-A-B-E-L. Hopefully that will be the last one. And yes, it is. So scrolling down, you will see your visual. And you can see that it is actually your predictions up here. 30-day forecast prediction is the dots. And you can see that it's going up. So between 225 and 250, closer to 250. So probably I'd say 245 or 240. So that is your prediction in the next 30 days. Since we used a relatively simple LSTM model for this forecast, so it may capture the general directions rather exact price values. So a more complex model or additional futures could make the forecast more reliable, but predicting stock prices remains challenging, very challenging. So in a summary, the plot shows both past prices and the model's 30 days forecast, helping you visualize potential future stock behavior. It does give a general idea of where the stock might go, but always consider this forecast as one part of the broader analysis, not as the exact predictor. So I hope this really does help you with your data analysis on predicting stock prices. Let me just throw this up here. So I want to say thank you again for watching. If you enjoyed this video or found it very helpful, please consider supporting my YouTube channel by hitting the like and subscribe buttons. Or you could even buy me a coffee. That link is in the description below. Your support means so much to me and it helps me continue creating valuable content. So any way you choose to support is greatly appreciated. So with that being said, thank you for watching and I will see you on the next video.